My name is Aziz Yokubjonov, and I'm a JavaScript enthusiast as well as a student. I've been doing programming for a few years now, and mostly it was C# and JavaScript. You can check out my page on Twitter if you want. And today we will be talking about managing state in Angular 2 apps with the use of centralized state and one-way flow. So before we get into that, how do we store state now? Oh, actually, please check out this link. And as I will speak, please, if you have any questions or something is not clear, please ask your questions in this app. This link is also in comments on the meetup. So how do we store state now? So it's a common practice to store state in components. So we have a component class, and we store our state as that class properties. And this way, we have a tree of components, and every component has its own state. However, as your app grows, and you start sharing your state and passing it around, one component mutates the state of another, and that causes the state of another component to update. And over time, you get more and more of these dependencies. And at the end of the day, you don't really understand what's going on in the application, what changes what and why. So how can we solve this and work around this? So one of the things we can do is that we can take out the state from components and instead have a one big centralized state. And this state will contain the state of all components in your application. But this still does not give us a control over the changes, right? Because any component can just mutate the state, and we don't have a control. So if we have 5 components trying to change state at the same time, what we need to do is we need to forbid our components to mutate the state. And we should have some kind of service that will change our state. And let's call it store, because that's where we store our state. And inside this, and the changes can only happen inside the store. So the state is read-only for components. But then how do we actually update it? And the answer is that even though components cannot mutate the state, they can tell the store how to mutate it. And they do it by sending sort of a message to the store, which we call an action. And action is just a plain JavaScript object with a required type property where we describe what needs to be changed. So in this case, the type is increment, and we tell the store that we want to increment some kind of value. You can also have more complex actions, and by passing an optional payload property. So for example, if your action type is add question, you can pass the actual question. So if we take a look at the app that I gave you a link to earlier, here's the simplified version of it. So normally, in an application like this, when we click the ask button, we usually just push a new string to an existing array, right? However, with one-way flow and centralized state, what we do is that we send add question action to our store. This way, our components don't change the state. Instead, they tell the store that it needs to be changed and what needs to be changed. And store, in return, gives a new and updated value to our components. But how does the store know that add question means add question, since it doesn't understand English, right? So to understand that, let's dive deeper into the structure of our store. So we have a store, and we have a state stored in our store. And then we have actions that are dispatched by our components. So who does actually mutate our state and return a new value? And the answer is something called a reducer. So it takes current state, it takes a dispatched action, and depending on the action, it mutates the state and returns a new one to the components. So let's take a look what reducer actually is. So reducer is simply a function with two arguments, state and action, which switches over action type. And depending on the action type, it mutates the state and returns a new updated state to our components. So just to reiterate, we have a state stored in the store, we have actions dispatched, and current state and actions go through a reducer, which performs changes and returns a new and updated state. Yeah, also notice that we do not push a new value to the state. Instead, we return a new array with all of the items from the current state and a new question. And we do it because reducers must be pure functions, which means that they do not change input values, and they do not depend on external state. What does that actually mean? So let's take a look. We have a function p that takes a and b and returns their sum. And it's considered pure. Here's a function that is not pure because it uses external state. And external state is variable n in this case. And it's not pure because if we keep passing the same value as x, we're not sure that someone's going to change n, and we will start getting a different output. And this is why this function is not pure, because pure functions always return the same output with the same input. Here is an example of a function that is not pure because it actually mutates the input value. So we pass x, which is an array, and we push 1 to that array. And if you know how push method works, then you probably know that it does not return a new array. Instead, it modifies the existing one. Here are many ways you can use that to return new values instead of mutating the existing ones. You can use object.assign to duplicate objects. You can use object spread operator, which is actually not officially released, and you need a special npm package to use it. However, the array spread operator works everywhere with ES6. Or another option is to use libraries such as immutable.js, which make it way simpler to change values without mutating. So just as a recap, we have one centralized state across the application. The only way to update that state is by sending actions to our store. And reducers must return a new state every time they run. So what are the benefits of having centralized state? If we have a centralized state, our business logic and presentation logic are separate, which means that which makes it way easier in your app to reason about it, and it allows you to create alternative interfaces for the same business logic. Another benefit is the ability to easily hydrate your app with data or import state, you can say. It also allows you to export the entire app state as an object if it's serializable. So let's see what that means to hydrate and export the state. So let's see there's Jimmy, and Jimmy has an app that stores user sessions somewhere on the server. And when his front-end app launches, he needs to restore those sessions exactly. So how does he do it? Normally, he would write bunches of code just to implement that. However, with centralized state, all he needs to do is pass his JSON state from local storage or cloud to the app, and it will work out of the box. However, notice that this only works if your application state is serializable, meaning that it can be converted to JSON. And in most of the cases, it is. Same goes for exporting the state. Since your whole application state is a single object, you can easily pass this object around and save it for local storage or send it somewhere in the database. What are the benefits of having one-way flow, meaning that all of the changes go through store and reducers? And the benefits are that our state becomes very predictable because all of the logic is in reducers. And reducers always return the same output with the same input, meaning that you can easily recreate the state as well as easily predict what your state will be. Another great benefit is testing. Since, as mentioned before, all of the logic is in pure functions. And pure functions are very easy to test because they do not depend on external values. And this way, you don't need any kind of test bed, or you don't have to mock any components in order to test your business logic. And definitely not less important, it's performance. With pure functions, and especially observables in Angular 2, you can use on-push change detection, which will your change detection much smarter, meaning that it will not run change detection in places where you don't really need it to. And this way, your app will be much, much faster than with default change detection. And this way, it's called on-push. You probably have heard of it. And last but not least, we have debugging and DevTools as a benefit. So let me show you how DevTools work. So here's the app that I showed you earlier. And let's add a couple of questions. So as I added questions, you can see that here are actions coming up in our DevTools. And that is because the only way to mutate the state is by sending actions. So here we can see all of the actions that happen to the state. We can see what the payload was, and we can see what was our state at that point of time. Moreover, we can also rewind those actions and replay them. So we can go to the initial state and then click the play button and see how actions are coming up. Now take a look at the list of the actions. We have 3 actions here, but in the UI we only have 2. There must be a bug somewhere, right? So let's see what causes the bug and where is it. So we can replay every action and see that on the second action, it did not add the question to the UI. And we can see that the question was, how wealthy is Bill Gates? And this way, by replaying the actions, we can always find a bug where we need it and when we need it. And here we can see that when we dispatch an action with this question, that it won't be added because there's a certain bug in the reducer.
What was the bug?
Oh, I added it on purpose. Yeah. So how do we actually use all of that in the applications? So here are two options. There is Redux, and then there is a library called NGRX store. Redux came first, and they both follow the same principles. However, the implementation is what's different, because NGRX store is based on observables. So let's see how we actually use NGRX store, because it's closer to Angular style. And yeah, so first of all, we need to npm install it. We install NGRX core and the NGRX store. Then we need to set up our reducers. So nothing really changes, except that I added types for the parameters so that our state is an array, and our action has an action type with two properties, type and payload. Besides that, it's the same switch construction and the same action types. Then we need to set up store in our module. And first of all, we need to import our reducers, or a reducer in this case, and a store module. Then we need to provide store in the imports and passing an object with our reducers. We can also have multiple reducers, and different reducers will handle different parts of your state. So this object inside of provide store represents the future structure of your actual state. So your state will have a structure of questions and suggestions. So let's see how we use store in our components. So store is an injectable, and that means that you can inject it anywhere in the application in any class. And store is also an observable, which means that it's asynchronous. And if you are familiar with promises, they are similar, except that promises give you values only once, while observables keep giving you values until you unsubscribe. So here's a way of getting the whole application state every time it changes. If your app is big and your app state is big, you don't have to subscribe to the whole thing. You can subscribe to little pieces of your state. And you do it with the use of a select operator, where you can select little pieces of your state without getting the whole thing. However, with select operator, since you're not setting the values anywhere, you also have to use an async pipe in your templates. And this way, it's more recommended than subscribing to the whole thing, because async pipe handles all of the subscribing and unsubscribing for you. And here's how we actually send actions to our store. So we use the store that we injected earlier, and we simply call a dispatch method and pass the required action to that method. if you want to learn more about NGRX store, Redux patterns, you can check out those links. I think they are very helpful, especially the session on Egghead by the creator of Redux. Also, earlier on AngularNYC, we had 2 speakers talking about NGRX store, and they were Pavan and Xavier. And I believe they are really cool, and you should definitely check them out.